All right, so number 51. We have a student who throws a set of keys vertically upward to his fraternity brother who's in a window 4 meters above. The brother's outstretched hand catches the keys 1.5 seconds later. So here's my diagram. So we got this guy down here, and he throws this set of keys, this object, straight up to this guy standing 4 meters above him. Okay? And we don't know what the initial velocity is. In fact, that's what the first question is. The first question is, what was the initial velocity? We don't know the initial velocity, but we are given the time. So the time of travel for the set of keys is 1.5 seconds. And we're told that the keys end up in this dude's hand final. So this dot is the final point. This dot is the initial point. Oh, you know what? So early in the year, this is a very common question I get. Kids ask about this distance in here. Well, how high did the guy throw the keys from? Are we told that? No. So you're basically assuming, I guess what we'll do is we'll say the 4 meters is measured from there. The 4 meters is measured from where the keys start. Does that make sense? 4 meters up. All right. So we got time. What else do we have? It's not specifically stated in the problem. Gravity. Once the keys are out of the person's hand, we know that the acceleration of the keys will be what? Gravity, which is negative 9.8 meter per second squared. Now, do we know V final up here when the keys are caught? No, we don't. And a very common answer would be, the velocity final is 0 because the guy catches them and the keys stop. Is that what we mean by V final? Like once they're in the dude's hand? No. What do we mean by V final up here? Right before the keys go into his hand, like the split second before the keys go into his hand. So we don't know what that velocity is. That's a question mark. Let me make a better question mark. Here's my best question mark. There. We don't know what that V final is. So guys, how the heck can we find V initial with the data that we have? Now I wrote the kinematics up here. Look at, why can we not use, so we're looking for V initial. I'm going to circle all the V initials. V initial, V initial, V initial, V initial. Okay, why will the second equation not work? We don't have V final. We don't know what V final is. Why will the third equation not work? We don't have V final. So the second equation is out, the third equation is out, and then guess what? The fourth equation is out. That leaves what? The first equation. This is the equation that's going to solve the problem. Okay? Now I want to kind of spoil the ending for you. I calculated ahead of time what's going to happen here. So I figured out that these keys are going to go up, past the dude, then back down. And I'll show you why later. You can show that. Okay? The keys are going to go up and back down again. Remember, this X right here, this X right here is a what? A displacement. What does displacement care about? Starting point, ending point, and the distance in between, which here is what? 4 meters. So X, the 4 meters, is our X. Even though the keys go higher than the dude and then back down again, right? So the displacement does not care about this. The displacement only cares about starting point, ending point, distance in between. Okay, so let's take our first kinematic. So we're solving for A, the initial velocity. So X equals 1/2 AT squared plus V initial t, and we're going to solve that for V initial. X minus 1/2 AT squared over t. Now plug in the numbers. So X is 4 meters. minus 1/2 times negative 9.8 times the time, which is 1.5. Oh, I knew I shouldn't have done this. I'm out of room. 1.5. You know what? I'm going to go lower. I want this to be money. So V initial, we're going to plug numbers in here. So 4 meters minus 1/2 negative 9.8. The time is 1.5 seconds. Square the time. Okay, what happens to these negatives right here? They cancel and become a plus, right? So when you punch this into your calculator, you're going to come out with positive 10 meter per second. That's the starting velocity of the set of keys. Okay? That's kind of a tricky one, huh? That's a tricky problem. Now, how can we prove that the keys go up past the guy and then back down again? We can show it. How can we show it? So stick that there. Okay, so part B, what was the velocity of the keys just before they were caught? Well, let's do that. So what was the velocity of the keys just before they were caught? Which kinematic would work for that? I'd use the third one. So this was part A. Here's part B. VF equals V initial plus AT. So now we are looking for VF. So this is actually going to show, this calculation here is going to show us that the keys went past the guy and then back down. V initial is 10 positive plus negative 9.8, and then the time is 1.5. Now, this answer comes out as negative 4.7 meter per second. What is this negative telling us? The keys are on their way down. At t equals 1.5 seconds, the keys are on their way down, which means that they must have gone up and back down. Does that make sense? Okay. And you know what I didn't show on the diagram that you really should show? You really should show the sign convention. Down is negative, up is positive. It'll help you keep track of things. Okay, any questions on this problem? Does that make more sense?